Greetings, ladies and gentlemen. In this video, we will be talking about relations and a special type of relation called a function. Now, a relation is any relationship between one variable and another, okay? Now, a special type of relationship, a function, is where for every independent variable that we have one and only one dependent variable, okay? Let's step back from a little bit from this math talk, and let's talk about the real world. So if we have a couple of credit cards, all right, and each of these credit cards has an independent account number, okay? So the idea is that each credit card, okay, is an independent variable, okay? Now this example will also explain the difference between an independent and a dependent variable. Independent variable is something that a user changes or inserts. A dependent variable is the result of what occurs, okay? Now, so we have multiple credit cards, and when we swipe the credit card through the credit card machine, what happens is that something goes on in the machine, okay? We can call whatever goes on a function, okay? So what goes on, function. So essentially, anything that takes the independent variable in is called a function. Now the dependent variable in this particular scenario would be the account, the specific account that the money is extracted from. See, the idea is that for every single card, there's only one account that the money essentially is subtracted from. That would be for every independent variable. You have one and only one dependent variable. It's not like for each card you can subtract money from two separate accounts. Okay, it's just a little example there. Okay. Now another example, we can go into numbers a little bit from here. Okay, let's say that we are doing an experiment. Okay, and we're looking at how the height of a plant is affected as time goes by. So let's say that the time here, t is equal to the time in weeks, and the height is equal, h is equal to the height in inches. All right, now the idea is that the time is your independent variable and the height is dependent. Why? Because your height depends upon how much time has passed or how much time has gone by. Okay? That's the dependent there. Now usually what happens is that when we're dealing with functions, we want to make a table of values. Your independent variable, okay, commonly known as x, by the way, so I'm going to make an arrow here. I'm going to say x. A lot of times we call that x, and our dependent variable, a lot of times we just call that y. All right. Now, let's say that we measure our plant height only once a week. All right. So let's say that in week 1 our plant is 5 inches tall, and week 2, let's just say it's continuously increasing. 3, it's 7. Or excuse me, week 4, it's 8, all right? So this looks like it's continuously increasing. Now the idea is that for each week, we can have only one time that we're measuring. We cannot have two measurements. If we had two measurements for each week, this would not be a function, all right? Now let's try to write these in something called ordered pairs, all right? I will write ordered pair over here, okay? Now, ordered pairs are usually written as parentheses, the independent variable, comma, the dependent variable. This is pairs over here, comma, the dependent variable. In this case, we will write this as a, in terms of ordered pairs. Our independent variable here seems to be 1. Dependent variable seems to be 5. Okay, so that's one ordered pair. Next one seems to be 2, 6, 3, 7, 4, comma 8. Right? Now the idea is that for each ordered pair, for each specific independent variable, there can only be one dependent variable. For example, this would not be, just looking at these ordered pairs, we can determine if it's a function or not. And this would not be a function if we had another ordered pair, let's say that said 1, comma 6. Because what this is saying is that in week 1, when we measured it, the height came out to be 5 and it came out to be 6. Now that does not make sense, okay? Because in one measuring, you can have only one height measurement. So the idea is anytime these values repeat, you do not have a function. If something is not a function, we call it simply a relation, okay? Now, let's look at graphs a little bit now. And I will erase this. Let's get a couple of graphs here. Now, the next question is, how can we determine if something is a function or not simply by looking at its graph? Well, example number 1 here, okay? We'll draw this. Example number 1 here looks like a function, or excuse me, looks like a circle, okay? And usually when we graph this horizontal axis is our x-axis, this vertical axis is our y-axis. Now, to determine if something is a function or not by the graph, we use what is called the vertical line test. All right. Now the vertical line test basically says that you take your pen or pencil when it's on paper, or in my case a marker, and hold it on the graph. And if my marker were long enough, what would happen in this case is it would touch 2 points. Vertical line test says that at each time that you put your pen or pencil on the graph, you should touch one and only 1 point, okay? Now this is not a function, and I can prove that by saying, if I were to come over here to on the x-axis, go up to the y, I can make a point here, come right and come down, I can make a point right here. Okay, so for this value on the x-axis, I seem to have 2 points. In other words, if I draw a horizontal line, or excuse me, a vertical line, my drawing is a little bit off. If I use the vertical line test, you can see that I cross 2 points at the same x value. Okay, now this x value, if my drawing was correct, would have been right here. All right. Now same thing over here and over here. The idea is that this relation is not a function. All right. Now let's look at another example, and let's call this example number 2. And this one, let's make it look like this. Okay, now this looks like a kind of curvy graph that goes on forever in both directions. If I were to take my marker and draw a vertical line here, I can see that at each separate time I draw the line, I touch only 1 point. If I touch only 1 point, what that means is that this is a function. This relation is a function. So I will write no over here for that no, this is not a function, and yes over here, that yes, this is a function. All right, now let's just do 2 more examples. I will do the third one, actually a little bit right here. Okay. Let's say that this graph looks a little bit like this. Okay? This looks almost like that, okay? And if we were to, this looks almost like example number 2, and if we were to take our marker and draw a vertical line here, you can see that on the line, or on the graph, or on the curve, we cross only 1 point, so you would be inclined to think that this is a function. However, if you draw your line right here, you cross 1, 2, and 3 separate points. Because you cross more than 1 point each time you draw the line, we can conclude that this is not a function and is simply an example of a relation. All right. Now, the last example will lead us into the next video. Okay. Now this is the example of a line. Okay, this is a line, and this there is a function for this. And well, I just said that this is a function, so I gave it away. But the idea is that if we make a vertical line here, at each point we can see that we're crossing the graph at one and only one distinct point. Okay, so therefore, yes, this is a function. Okay, now that would be all for this video. If you have any further questions, please let us know.